Hi there folks, this is Mr. Jansen, and this is just a quick review of the area worksheet that we were looking at. Hopefully you've had a chance to take a look at the answer key, but I'm just going to run through this real quickly. For these first couple, these really straightforward ones, you just have to remember the formula, and I should have put in here to assume that these were these ones that look like parallelograms are parallelograms. Remember, the area of a parallelogram is just area equals the base times the height. So that's all we're doing for these. And so for these first four, you're just doing the base times the height, and just make sure you remember that the base and the height have to be perpendicular. The first one's straightforward, 14 times the 3. The second one's got to be the 10 times the 8. You ignore the 9 because, again, the base is 10, the height is then 8 because those are perpendicular to one another. The next one, the 2.5 is the base, the 4.8 is the height. Number 4 is probably the trickiest one, where the base is actually the 8. Kind of turn this thing to that perspective. So the 8 is the base, the 12 is then the height. Again, base and height have to be perpendicular. Same thing with the triangles. Remember, the formula for triangle is area equals 1/2 the base times the height. It's just half a parallelogram. And so, again, the base and the height have to be perpendicular to one another. So for number 5, I use the 11 and the 3, obviously. Number 6, I have to use the 9 and the 6 for base and height. So I kind of have to turn this thing to make sure that those are perpendicular. Base and height have to be perpendicular. Number 7, I use the 7 and the 5.5. The 2 just gets ignored. There's no reason for that. It's just there to distract you a little bit. The idea is you're trying to be tricked into doing something like you have to do for number 8. Number 8, the base is the 8 plus the 5. It's that entire bottom side, so you get the 13, and then times the 6, and then times the 1/2. And then number 9, same as number 7. The base is 5.5. The height is 10.4. You ignore the 5 that's in there. Okay? For these, you just have to look at the parallelogram. This goes back to that base and height have to be perpendicular. So you have to look at these from two different perspectives. If you look at it from one perspective, the base is 8 and the height is 3. But then if you turn this thing so that the side that's to the left right now is on the bottom, then the base becomes 4 and the height becomes h. So you're just saying, okay, this is the same parallelogram either way. From one perspective, it's 8 times 3 for the area. From another perspective, it's 4 times h. So those have to be equal because they're representing the same area. So I do the 8 times 3 times the 4 times h, and then I solve for h. Same thing with the next one. From one perspective, the base is 7.8 and the height is 6. From another perspective, the base is 6.5 and the height is h. So I set those equal to each other, and I solve for h. Number 12, same thing. One perspective, the way it's drawn, 3.8 times the 4, that's base and height. But from another perspective, it's the 9.5 and the h, so I just set those equal to one another. For these, there's a couple ways to approach these. Most of you for number 13 probably drew this line across the top to create a square. And then from there, you take the area of the square minus the area of this triangle that I've just created, which this triangle has a base of 14 and it also has a height in here of 14 as well because of this side. So then you can find the area of that triangle and subtract it from the square. The interesting thing about that is you're going to find out that it's actually half of the square. And so the other way you could look at this is if you were to kind of take this triangle right here and bring it off to the side, over onto this side. So you still get a base the whole way across of 14, and you still have a height of 14, then you do 1/2 the base times the height. So it's interesting that you can do it in those two different ways, but anytime you draw a triangle within a square, the area is going to be split in half between the triangle and the other two triangles. Number 14, you just have to find the area of each of these, so you do the area of the parallelogram, base times height, that's where I get the 100. And then you do the area of this triangle separately. That's 1/2 the base times the height. The base is 14, the height is 10, and that's where I get the 70, and then you just add those together. This one, you can see that I dropped a perpendicular line to create a rectangle. So I dropped that perpendicular line, and then where I get the 9.5, this side over here is a total of 16, but if I take away this piece, the 6.5, it just leaves me with the red dotted line, which is the 9.5. I did the same thing going the other way. I knew the entire side down here was 14, but I knew that this little piece right here was 5, so then I knew that this piece of the triangle was only 9. Alright, so you might have to do a little bit of segment addition here, subtraction and addition, but it's just our segment addition postulate. So now I have a rectangle. I do the area of the rectangle, 5 times the 16, that's where I get the 80. I do the area of the triangle, 1/2 the base times the height, using the 9 and the 9.5. And then I just add those together. This one I've got to draw a picture. It gives us a ratio, so remember I labeled the 5 and the 3, but then there could be a multiplier with those, so I use x. So then 5x times the 3x equals the area, which is the 135. And then I just solve. I divide by the 15, and then I have to take the square root, and then I got to plug those back in to find out what the actual base and height are. Number 17, this is kind of a strange question to ask me of all the different bases and heights that I could have. So if the area was 18, I just do 1/2 the base times the height. If I get rid of the 1/2 by multiplying by 2, I get base times height equals 36. So basically I just need combinations that give me 36 when I multiply. So I could have a base and a height of 1 and 36, and the 1 could be the base and the 36 could be the height. The 1 could be the height and the 36 could be the base, either way. Or I could have a base and height that are 2 and 18, or a base and height that are 3 and 12, or a base and height that are 4 and 9, or a base and height that are 6 and 6. So I have lots of different triangles that meet that condition. That's kind of the point of the question, is there's a lot of different values there. Number 18, this is probably the most challenging, well, one of the most challenging ones on here. But if we draw the whole thing, I've got a base of 7 and a height of 6, and that's written in black over there. I also did the area of just that piece over on the side. That's 42. And so this is the area of the entire parallelogram is 42. And then I did the area of just this triangle on the top up here, ADB. And I found that that's half, or it has to be half, sorry about that. That's half of the overall parallelogram, so that's 21. And then what happens is I found the area of just this guy, just this triangle up here, AED, and see I have a base of 7 and I have a height of 3, so I do 1/2 the base times the height and I get the 10.5. Well, if I know the area of this entire triangle up here is 21, and I know the area of this triangle is 10.5, if I subtract, it should leave me with the area of just this triangle, the ABE, which is also 10.5, and so it's kind of this neat thing. I get two completely different triangles that have the same area within that thing. For these, straightforward, I need to know my formula, so the area of a trapezoid, and again I should have said that assume these are trapezoids, but it's the area equals 1/2 the height times the bases being added together. So 1/2 the height times the bases added. And so I just plug that in. Here the height is 10 and the bases are the 16 and the 9. And again, the height has to be perpendicular to the bases again. Next one, the height is 7.5 and the bases are 9 and 22. And then the last one, the height is 7 and the bases are the 13 and the 4. Area for a kite. It's just area equals 1/2 the diagonals being multiplied, so d sub 1 times d sub 2. So I just come up with the diagonals. This one diagonal is a total of 8, the other diagonal is a total of 8.5. Multiply them together, divide by 2. This one I've got a 6 and an 8 for my diagonals, multiply together, divide by 2. The next one I have a 15 and a 12 for my diagonals, and I plug it in. Area for a rhombus. Again, the rhombus is special because I could just treat it like a parallelogram and do base times height if I'm given that kind of stuff. When I'm not, when I'm dealing with the diagonals, it's the same as the area for the kite. So this one, again, the one is 50, the other one is 44, multiply together, divide by 2. This one I have to come up with that missing side. I know that this piece over here is 4, so I have to use my Pythagorean theorem. A squared minus b squared equals c squared. 6 is the c squared, so I get the 36, and then I solve that. I end up with a 2 root 5, which means that entire diagonal is 4 root 5, and so I still do the same thing, 8 times the 4 root 5 divided by 2. The next one, I have to draw the other diagonal because it's not drawn, which splits that first diagonal in half, so I get 5 and 5. I again have to use my Pythagorean theorem to find the missing piece. So I do the a squared plus b squared is c squared. Again, 8's going to be the c squared part of this thing. and then I solve and I get the square root of 39. So then one of these is 2 square root of 39. The other one is 10 square root of 39. I multiply together and divide by 2, and I think I made a mistake there. Let's see. 10 times 2 is 20 divided by, that should be a 10. Sorry about that. 10 square root of 39. This one, again, using that formula for the trapezoid, I just have to recognize that entire bottom piece has got to be a 13. I also have to use the Pythagorean theorem to come up with the height, which is the 4 root 2. And then I do 1/2 the height times the bases added together. The next one, again, I use the Pythagorean theorem to come up with the height, and it's the same set of numbers, so that makes it a little bit easier. And then I do 1/2 the 1/2 the height times the base, and keep in mind again this base over here is a total of 10, so just be careful with that. So 1/2 the height times the bases added together. Okay. Next one, same kind of thing. Although I think I made a mistake on that one too. Oh boy, Mr. Jansen, you are losing it today. So this one's 1/2 the bases added together, so it's going to be 17. I forgot to add the 2. So it's 17 times the half of 4, so it's 34 root 2. There we go. This one was 10 root 39. Sorry, I'm rushing a little bit. If I look at this one is probably the most obnoxious one on here, and if you couldn't leave this, this is one that I would probably ask you for in terms of a decimal, because as you start to do your 30, 60, 90 triangle, you find out that the side over here is 5, so this side over here is 5 root 3, which means this piece of this rectangle over here is 14 minus 5 root 3, which means this side is also 14 minus 5 root 3. So then the two bases are the 14 and the 14 minus 5 root 3 times 1/2 the height. And so that one's a little bit ridiculous. This is what it would be in exact form. But again, I wouldn't be expecting that. I would be expecting that one as a decimal. Okay? This one, you got to do your 30, 60, 90 triangle. So if one side is 6, the short side is 3, the long leg is 3 root 3, and then you do the diagonals, which is 6 root 3 times 6, and then divided by 2. This one, 45, 45, 90 triangles, so the legs are all the same, so they're all 4. So now we're just doing 8 times 8 divided by 2. This one, the 30, 60, 90 triangle, you have the short side, you need the long leg, so it's 7 root 3. So now we're doing 14 root 3 times 14 divided by 2. This one diagonal of the rhombus is 5 less than twice the other diagonal, so find the length of each diagonal if the area is 75 centimeters squared. So I just drew a rhombus here, and I labeled one as x and the other one as 2x minus 5. And so then I plug it into my formula. So it's 1/2 x times 2x minus 5. I multiply this out, I get x squared minus 2.5x equals 75. I subtract the 75, and then it's a pain to try to build a bridge here because the 2.5. So I just multiplied everything by 2 to make it 2x squared minus 5x minus 150 equals 0. And then I build a bridge, I factored this thing, and I find out that it factors into a 2x plus 15 and an x minus 10. And then I set each of these equal to 0. And I get two answers. One of those answers is negative, which is ridiculous for a length. The other one works, so it's 10. I plug it back in, so I find out that one diagonal is 10, the other diagonal is 15. And obviously, I actually have my drawing backwards in terms of it being drawn to scale, and that's okay. I didn't know which one was going to be the longer leg when I started. This one, we draw the trapezoid. It's got 2 right angles. It tells me that the altitude is 5 inches long. But it also creates an isosceles right triangle, which kind of tells me that if this is 5, this is also 5. And so then from there, what I can do is just come up with the area of this rectangle and then the area of the triangle separately, or I can do my theorem, just understand that this guy right here, that's a total of 14, and so that's where I get my two bases from. Okay? And then this last one, an isosceles trapezoid, it's telling us which two sides are parallel to tell us how to draw this trapezoid. And then we've got the FG equals 10, we've got the GH, we've got the measure of E, so I just label those things. I know that the base angles are the same, and then from there, the 30, 60, 90 triangle, I go from the 6 to the 12, from the 12 down to the 6. I know that the other side has to be the same. I know that the height then is 6 root 3, so I'm just using those 30, 60, 90 triangles. I'm using the fact that each side is the same, and then I plug it into my trapezoid formula. Okay?